In this lesson, I will teach you how to convert rectangular coordinates to polar coordinates. Recall that the polar coordinate system uses r and theta to plot, whilst the rectangular or Cartesian system uses x and y. Before we jump into an example, here are the following formulae we're going to be working with when we're converting our xy pair into polar coordinates r theta. This table is also going to play an integral role in converting from rectangular to polar. Depending on the quadrant our xy pair lies in, we may need to make adjustments to theta after we've calculated theta using this formula. On to example 1. We're asked to convert the rectangular coordinates 3, 4 to polar coordinates. Step 1, let's substitute our values for x and y into these equations. For r, we have the square root of 3 squared plus 4 squared. That gives us the square root of 25, which of course is 5. Let's now plug our values into our formula to calculate theta. Inverse tan of 4/3, or you might say arctan of 4/3, will give us 53.13 degrees if we pop that into our calculator. We may not be done just yet, so let's work through our other 3 steps to see if any alterations need to be made to theta. Step 2, we need to identify the quadrant that our xy pair lies in. Our original pair 3, 4 lies in quadrant 1, as both x and y are positive. Step 3, check over our table to see if any alterations need to be made. Since our xy pair lies in quadrant 1, we can see that no alterations need to be made to theta, so step 4, we can conclude that our rectangular coordinates 3, 4 translate to 5, 53.13 degrees in polar coordinates. A second example, convert the rectangular coordinates -1, -1 to polar coordinates. This time we need to keep our answer to theta in radians, not degrees. Step 1, let's substitute our values for x and y into these equations. We will find that r is equal to the square root of -1 squared plus -1 squared. That leaves us with the square root of 1 plus 1, so root 2. Let's leave this in radical form as 2 is not a perfect square. Okay, let's calculate theta. Arctan or inverse tan of 1 gives us pi on 4. If you haven't yet memorised your trig identity values, you can use this table here to help. We can see that the inverse tan of 1 gives us pi on 4. So we have r equals root 2 and theta equals pi on 4. Remember that we may need to make alterations to theta depending on what quadrant our xy pair lies in. -1, -1 lies in quadrant 3. Step 3, take this information to the table and see if there are any alterations that need to be made to theta. We can see that if our xy pair lies in quadrant 3, we need to add pi to theta. Remember that we're working in radians for this question, so I focus on this element. If we were working in degrees, I would simply add 180 degrees to theta. Okay, so we need to add pi to theta. Let's do that. The theta we calculated equals pi on 4. Adding pi to that, pi on 4 plus pi is the same as pi on 4 plus 4 pi on 4. 4 pi on 4 really just equals pi, but I converted it to this fraction to make addition easier. Pi on 4 plus 4 pi on 4 gives us 5 pi on 4, so now we have our new theta. Step 4, write out the polar coordinates. We have r equals root 2 and theta equals 5 pi on 4. So we can conclude that the rectangular coordinates -1, -1 translate to root 2, 5 pi on 4. How about one final example? Let's convert 2, -4 to polar coordinates. Theta is to be represented in degrees this time. Step 1, substitute our xy pair into the formula. So for our r, we have the square root of 2 squared plus -4 squared. This gives us root 20, which can be broken down into the square root of 4 times 5, simplifying again to give us 2 root 5. For our theta, we have inverse tan of -4 on 2. This gives us inverse tan of -2. If we pop that into our calculator, we get -63.43 degrees. Step 2, identify the quadrant our xy pair lies in. 2, -4 lies in quadrant 4, so let's take that to the table. Since our xy pair lies in quadrant 4, we can see that we need to add 360 degrees to theta. Remember that we're working in degrees, so we focus on this element of the table, not the radians element. Let's make our adjustment. The theta we calculated is -63.43 degrees. Adding 360 degrees to this gives 296.57 degrees. Therefore, we can conclude that 2, -4 in rectangular coordinates is equivalent to 2√5, 296.57 degrees in polar coordinates. That completes our lesson on converting rectangular coordinates to polar coordinates. I'll see you in our next lesson. Bye.